All right, Chapter 1, Lesson 9 is direct variation. Okay, the warm-up here says the distance y a car travels after x hours can be represented by the equation y is equal to 65x. The table and the graph also represent that situation. So here is the table. If it was 2 hours, they would have driven 130 miles. 3 hours, 195, and 4, 260. And this is the graph. So we're graphing 2, 130, 3, 195, and 4, 260. Number 1 says fill in the blanks to find the constant ratio. So we're talking about the distance traveled to the driving time. Okay, that is the ratio that we're looking at, or the rate that we're looking at. So if I look at all of those rates, the first one is 130 to 2. The next one would be 195 to 3. And the next one would be 260 to 4. Very good. Now if I simplify all of those to a unit rate, what would I get? We would get 65 over 1 for each one if we simplified those two unit rates. So that means that the constant ratio is 65 over 1, which represents 65 miles over 1 hour. So that's 65 miles per hour. So number 2 says now we're going to find the constant rate of change or the slope. Remember, constant rate of change, slope, the unit rate, they're all the same thing, okay? So again here, the constant rate of change is found by finding the change in the miles over the change in the time. So when we're finding the delta y over the delta x, we're just subtracting, right? So here we would subtract the y values, so that's 195 minus 130, and we would subtract the x values, which is 3 minus 2. So when we do that, we get 65 over 1, which again is 65 miles per 1 hour. Is everybody clear with that? So what does that tell you about the rate of change and the constant ratio? So that tells us that the constant rate of change and the constant ratio are the same thing. All right, so direct variation. Direct variation, in a direct variation equation, that is a linear relationship when a ratio of y to x is constant. So when we're looking at the ratio of y to x, it will always be the same. So it says a linear relationship is a direct variation when the ratio of y to x is constant. And that constant that we're going to use is the constant k. Okay? We say that y varies directly with x. That's what we say when an equation has direct variation. Now, I want you to write down this information right here in symbols. Okay? It says when we're looking at a direct variation equation, it looks like this. The ratio of y to x, y over x, is equal to k. Is equal to k. Okay? Now, if I wanted to write that as an equation, if we had y over x is equal to k, and I wanted to write that as an equation of a y equals, then I would just use my inverse operations here to move that x to the other side, right? I would just multiply times x there and multiply times x there. So here, those x's will cancel, and then y is equal to kx. And that's how we get this equation right there. Is everybody with me? So now if I look at the model, does it look familiar?
Yes.
What kind of line is it? It's a linear equation, right? It's a straight line And where does it go? It passes through the origin. So direct variation simply means what? Proportional. Is everybody clear? Okay. All right, when two variable quantities have the same constant ratio, their relationship is called a direct variation. Make sure you write that down. When two variable quantities have a constant ratio, their ratio is called a direct variation. And of course, that constant ratio is the K that we were talking about, right? Constant ratio K. The constant ratio is called the constant of variation. The constant ratio is called the constant of variation. So K is the constant of variation. And the constant of variation is also called the constant of proportionality. Now, in a direct variation equation, I want you guys to make sure you write this down too. In a direct variation equation, the constant rate of change, or the slope, is assigned a special variable, k. And please notice again here, the constant rate of change and the slope are the same thing. So for example 1, it says the height of the water as a pool is being filled is shown in the graph. We want to determine the rate in inches per minute. So we're looking at inches per minute. So if I'm looking at inches per minute, that's going to be the y value, see that's inches, over the x value, which is the minutes. So everybody see that? So inches per minute is y over x. Again, delta y over delta x, right? So here it says, if I'm looking at the graph, see, since the graph of the data forms a line, the rate of change is constant because it's a straight line. And because it goes through the origin, we know it's proportional. And because this line is proportional, we know that it has direct variation. So let's prove it. So if I look at each one of our rates, here this is going to be 2 to 5. Okay, because remember we're looking at y to x, so it's 2 to 5. 2 to 5 is equal to 4/10 over 1. On this point, at this point here, this is 4 to 10. 4 to 10, 4/10 is also 4/10 over 1. Over here, this one, 6 to 15 is equal to 4/10 to 1. And same thing with 8 to 20. Same thing. Now, because every one of the rates are the same, it has a constant rate of change. And because it has a constant rate of change, it has direct variation. And what this means that the pool fills at 4/10 of an inch every minute. For this example, it says 2 minutes after a diver enters the water, he has descended 52 feet. After 5 minutes, he descended 130 feet. At what rate is a scuba diver descending? So we're trying to find the rate. So if I look at this, the first rate that we're looking at, that it tells us in the problem, it says 2 minutes after the diver enters the water, he has descended 52 feet, right? The second rate says after 5 minutes, he descended 130 feet. So if we're writing our rates, and we're going to do feet per minute, we're going to write our rates and then we're going to compare them. So here we've got, for the first rate, it's 52 feet in 2 minutes. The second one is 130 feet in 5 minutes. All right, so now we want to compare them. So we're going to write them both as unit rates. So we're going to divide the numerator and the denominator here by 2. And what are you going to get? 26 over 1. So that's 26 feet in 1 minute, right? Now, for the second rate here, we're going to change that to a unit rate by dividing by 5. Very good. So that's going to be 26 over 1. So that one also is 26 feet in 1 minute. So the rates are the same, right? The rates are the same, so what does that tell me? It has a constant rate of change, which means that it's proportional, which means that it does have direct variation. Very good. Now, so to answer the question here, at what rate is the scuba diver descending? What would you say? Very good. So the scuba diver is descending at 26 feet per minute. So make sure you write that down. So for the next example, it says the equation y is equal to 10x represents the amount of money y Julio earns for x hours of work. So we want to identify the constant of proportionality, and we want to explain what it represents in this situation. So you already can see from the equation which one is the constant of proportionality, right? Constant of proportionality is 10. Does everybody see that? Because remember, the constant of proportionality is k. So in the equation y is equal to kx, the constant of proportionality is k, and in this one, it's 10. Well, we want to know what it means. Okay? So here, when we're looking at our equation, we have y is equal to 10x. Now remember, we want to find out what the constant of proportionality is. In other words, we want to know what is the rate of change. The rate of change is the delta y over the delta x. So how am I going to change this y is equal to 10x to a y over x? All right, so we are going to divide by x on both sides. Bless you. And so now those x's cancel out, and look at what we have. We have y over x, which is the constant rate of change, right? The delta y over delta x. That is equal to 10. And that's what we said from the beginning. Is everybody with me? So here, the constant of proportionality is 10. Now the y value, it says, what does the y value represent? The amount of money, right? So this is going to be dollars, and the x value represents the hours of work, right? So this is going to be over x hours. So if I want to continue this, I can put this 10 over 1. So that tells me that Julio earns $10 for every 1 hour. Does everybody see how the correlation there? So Julio earns $10 for every hour that he works. All right. right. So in this got it problem, it says the distance y traveled in miles by the Chang family in X hours is represented by the equation y is equal to 55x. Now remember, the y is the miles they traveled, right? And the x is the hours that they traveled. Is everybody with me? Okay, so now when I start with my equation, y is equal to 55x. We want this equation to look like the rate of change. So it's going to be y over x is equal to something. So we want to move this x to the other side. You with me? So how do I move that x to the other side? You're going to divide by x on both sides. Beautiful. So now those x's will cancel, and we're left with y over x is equal to 55. Okay? Now, once again, the y represents miles, right? And the x represents hours. So if I want to put this 55 in the form a over b, I can just put it over 1, right? So the 55 represents miles, and the 1 represents the hour. So here, the constant of proportionality, what was the k? Is 55. And what it represents is that the Chang family traveled 55 miles per 1 hour. Is everybody clear? All right, for example 3, it says pizzas cost $8 each plus a $3 delivery charge. We want to show the cost of 1, 2, 3, and 4 pizzas, and we want to know, is there direct variation? Now, the equation that we're going to look here says $8 each plus a delivery charge. So that means the total cost is going to be equal to 8 times the number of pizzas plus that $3 delivery charge. Is everybody with me? And that's how we get to fill in our chart. Okay, so 8 times 1 plus 3 is 11. 8 times 2 plus 3 is 19, and so forth. You got it? So now when we graph it, this is what it looks like. So if I look at all of the rates, we've got 11, we've got 9.5, 9, and 8.75, 8 and 75 hundredths. Are the ratios the same? There is not a constant ratio. And what else do I notice here from the graph?
It doesn't go through the...
It does not go through the origin. It is a straight line, but it does not go through the origin. So there is no direct variation. Does everybody understand? This, or before in our previous lessons, we would say it's not proportional. Do you see that? So if it's not proportional, it does not have direct variation. Example C says 2 pounds of cheese cost $8.40. We want to show the cost of 1, 2, 3, and 4 pounds of cheese. And we want to know, is there direct variation, and explain. So we know that 2 pounds of cheese cost $8.40, right? Here I made a table. Then we're going to compare the cost to the weight. Okay? So it started out $8.40 for 2. So how much does 1 pizza cost? $4.20. So for 3 pizzas, So that we're just going to multiply $4.20 times 3, right? That's going to be $12.60. And then so $16.80 for 4 pizzas, right? Okay. So now we can graph it. And when we graph, we have, let's see, one cost $4.20. 2 pizzas cost $8.40. 3 pizzas cost $12.60. And 4 pizzas cost $16.80. All right. Now, when we look at the graph, this is what it looks like. Right? So this graph is a straight line, and it goes through the origin. And it goes through the origin. So, is it proportional? Yes. So that means that it should have direct variation, correct? So, let's check our ratios so that we can see if the ratios are constant. So, the first ratio is 420 to 1. If I change $8.40 to a unit rate by dividing by 2, what am I going to get? $4.20 to 1. If I change $12.60 to a unit rate, what are we going to get? $4.20. And if I change $16.80 to 4, that is going to be $4.20 for 1 pizza. So because the rate of change is constant, that is a constant rate of change, do we have direct variation? Yes, we do. Very good. All right, for example 4, it says, determine whether the linear relationship is a direct variation. If so, state the constant of proportionality. Remember, the constant of proportionality is the K, right? It is also the unit rate, okay? It's the R to 1. So here, the first thing we're going to do is we're going to check to see if all the ratios are the same. So here, the first one is 12 to 1. Yep. 24 to 2 simplifies to 12 to 1. 36 to 3 simplifies, good. And 48 to 4 simplifies. So, since there is a common ratio that is the same every time, the relationship is a direct variation. Now remember, to find the constant of proportionality, it is the one that compares to 1.